Good morning. Welcome to GATE online video. Today I am going to take Boolean postulates and laws in Boolean algebra. I am Ramya, Assistant Professor, Department of ECE, S.A.ENG.COLLEGE. First, let us see the basic operations in digital circuits. So, we are familiar with the operations. First one is AND operation. The AND operation will return true value when both the input is true. And next is OR operation. It will return true value if at least one input is true. Next is NOT operation. This will reverse the input. Next is XOR operation. Will return the true value if exactly odd number of inputs are true. NAND operation returns false value if both inputs are true. NOR operation returns false value if at least one input is true. Next is XOR operation returns true value if both the inputs are true. So these are the gates operations which is very important for digital. Next we can deal about postulates and laws of Boolean algebra. In that the first postulates, and these postulates can also be given in OR form or in AND form. So first postulate is identity. So identity in OR form, it is given by P plus 0 equal to P, and in AND form it is given by P dot 1 equal to P. Second law is idempotent. In OR form it is given by P plus P is equal to P, and in AND form it is given by P dot P is equal to P. The third law is commutative law. So it is given by P plus Q is equal to Q plus P, and in AND form it is given by P dot Q is equal to Q dot P. Next law is associative law, which is given by P plus Q plus R is equal to P plus Q plus R, and in AND form it is given by P dot Q dot R is equal to P dot Q dot R. Next law is distributive law, which is given by P plus Q dot R is equal to P plus Q dot P plus R. In AND form it is given by P dot Q plus R is equal to P dot Q plus P dot R. Next is inversion law. Inversion law, in both the cases it is A double dash is equal to A. Next is De Morgan's law, which is very important law, which is given by in OR form P plus Q the whole dash is equal to P dash dot Q dash, and similarly in AND form it is given by P dot Q the whole dash is equal to P dash plus Q dash. And next is complement, which is very important. P plus P dash is equal to 1, and in AND form it is given by P dot P dash is equal to 0. Next is domination law. Domination law is given by P plus 1 is equal to P, and in AND form it is P dot 0 is equal to 0. Next is double negation law, which is given by P double dash is equal to P, and similarly AND form also it is quite same, P double dash is equal to P. The last law is called as the absorption law, which is given by P plus P dot Q equal to P, and in AND form it is given by P dot P plus Q is equal to P. Let us see how this absorption law is working. So actually in LHS we have P plus P dot Q. We can find why it is equal to P. So let us take P as common. While you are going to take P as common, the value will be 1 plus Q. So already we know the law, that is 1 plus Q. From the domination law, it is very clear that the variable plus 1 is equal to 1. So obviously Q plus 1 will be equal to 1. So the value is P. So that only we are getting that P plus P dot Q is equal to P. Similarly in AND form, we have LHS as P dot P plus Q. So let us expand this. So P dot P plus P dot Q. From these two terms, we can take p as common. So you will be getting p plus p plus q. Okay, so p dot p plus p dot q is equal to, okay, similarly on the other side, if you are going to expand this, if you are going to solve this, you will be getting p dot p plus q is equal to p. Let us go with the first gate question, which is asked in the year 2024. The question is, for a Boolean variable x, which of the following statements is or false? Okay, and they have given 4 options. That is, A option is x dot 1 equal to x, B option is x plus 1 equal to x, C option is x dot x is equal to 0, D option is x plus x bar is equal to 1. Let us check which option is false. So we have to compare all these options with the laws which I told now. Okay, so we have to check each term is of which law. Let me take the first term. First term is variable dot 1 equal to x. So let us compare this with the identity. So what we had? We had x dot 1 equal to x. So the same pattern is available in identity law, that is p dot 1 equal to p. So our choice is x dot 1 equal to x. So it implies A option is right. Let us compare the B option. The B option is, the given choice is x plus 1 equal to x. Let us compare with this. Okay, so that is relevant to domination law. So p plus 1 is equal to p, but our choice is x plus 1 equal to x. So it is very clear that B option is wrong, because it is not going to satisfy the domination law. And third choice is x dot x is equal to 0. Let us compare x dot x is equal to 0. It is quite same as the idempotent law. What is idempotent law? P dot p is equal to p. So variable multiplied by a variable will be equal to the variable. Okay, but here it is given that the variable multiplied with a variable is equal to 0. Obviously this choice is wrong. Let us go with the final choice. X plus x bar is equal to 1. Let us compare this with our laws. X plus x bar is equal to 1. This is quite same as the complement law. So what is the complement law? P plus p dash is equal to 1. So this is right. Okay, so from this it is very clear that choice A is right, choice D is right. So choice B and choice C is wrong. So usually we will be having in the mind that there will be only single option, but that is not the case. In some cases there might be 2 options, some cases there might be 3 options. Okay, so let us go with the next question. So the next question is asked in the year 2019. Okay, which one of the following is not a valid identity? Okay, and they have given 4 choices. Let us compare each and every choices. Okay, what is your first choice? First choice is x, XOR of y, XOR of z is equal to x, XOR of y, XOR of z. So when we look into this, it is very clear that this is going to satisfy the associative law. So since it is going to satisfy the associative law, this is a correct choice and correct identity. Let us go with the second choice. So what is the B option? The B option here given is x plus y, XOR of z is equal to x, XOR of y plus z. Okay, so here when we look into this, it is somewhat a replica of commutative, it is somewhat replica of associative, but completely it is not satisfying the commutative law. So commutative law means x plus y equal to y plus z, but we have one more variable. If it is associative law, all the operators should be same, but here one of the operator is plus, the other operator is XOR. So 100% this B choice is wrong. Let us see the third choice. So third choice is x XOR of y is equal to x plus y. Let me take the LHS side. What is the LHS? LHS, it is x XOR of y. So x XOR of y can be expanded as x bar y plus x y bar. And what is the if statement they have given? If xy is equal to 0. Okay, they have mentioned that xy is equal to 0. So let me take y is equal to, because x or y, both the thing is 0. Let me take y is equal to 0. If I am going to substitute in this, x bar dot 0 plus x, we know that y bar means complement of your y. So the complement of 0 will be 1. So something multiplied by 0, this term will be 0 and final term is x. This is our LHS. Let me check with the RHS. Similarly, let me take RHS. Okay, let me have this as 1. Let me take RHS. RHS, it is given as x plus y. And what is the given thing we have taken? Y is equal to 0. Let us substitute y is equal to 0 here. When y is equal to 0, obviously the value will be equal to x. So this is your 2. So x 1 and 2 are quite same. So it implies that this is right. Okay, this is right, this is right. Let us see the fourth choice. Let us see the fourth choice. What is your fourth choice? X XOR of y is equal to xy plus x dash y dash the whole dash. Okay, let us expand the equation. Let me take the LHS. In LHS, what is given is x XOR of y. So we know the XOR equation. So XOR equation is x bar y plus x y bar. Okay, let us have this as equation number 1. Okay, so let me take the RHS side. RHS, it is given as xy plus x dash y dash the whole dash. Okay, when you look into this, it is very clear that this is of De Morgan's theorem. Okay, now we have to apply the De Morgan's theorem here. So while we are going to apply the De Morgan's theorem, we know that a plus b the whole dash is equal to a dash dot b dash. Okay, by using that principle, we are going to expand this equation. So what is this? A is xy. So whole dashes, let me take whole dash and dot x dash y dash the whole dash. This is your De Morgan's theorem. So we know that De Morgan's theorem is a plus b whole dash is equal to a dash dot b dash. Okay, in this term I have expanded this. Again, this is of De Morgan's theorem, that is a dot b the whole dash. Okay, so let me apply the De Morgan's theorem again and let me expand the equation x dash plus y dash into, so this is also De Morgan's theorem. So let me expand this. We know that a dot b the whole dash is equal to a double dash plus y double dash. Okay, so x dash plus y dash. Okay, so we know that x double dash which is nothing but x double bar. Okay, so x double bar is nothing but x plus, and we know that y double bar is nothing but y. Okay, so y. So now just let me multiply the each and every terms. X dash dot x plus, I have multiplied this term with this term, plus I am going to multiply this term with the other term. So x dash dot y plus x y dash of x y dash plus y dash. So from the laws we are very clear that a dot a dash is equal to 0. So this term and this term will be equal to 0. Now what is the final term we are getting? X dash is nothing but bar y plus x y bar. So let me take this as equation number 2. So now let me compare equation 1 with the equation 2. It is very clear that this equation and this equation is exactly same. So which means that D is right. Okay, so we saw that this satisfies associative law, so this choice is right, and I have explained you how you got this. So this choice is right. So the final choice which is wrong is B. So which is not a valid identity is your B choice is not the valid identity. Okay. So this is this year, that is 2025 question, and it is a 2-mark question. Which of the following Boolean algebraic equations is or are correct? Okay, and they have given the 4 choices. First choice, second, third and fourth. Let us solve each and every choices. Okay, let me take the first choice. First choice. Okay, in this I have to check whether my LHS is equal to RHS. Okay, so I am not going to disturb my RHS. Let me take LHS. So what is my LHS? A dash B C plus A B bar C bar plus A bar B bar C bar plus A B bar C plus A B C. Okay, let us simplify this equation. So the given equation is A bar B C plus A B bar C bar plus A bar B bar C bar plus A bar. Okay. Okay, let us take the first term and let us simplify it. A bar B C plus A B bar C bar plus A bar B bar C bar plus A B bar C plus ABC. This is your first LHS equation, and we can see which is common here. Okay, so from the first and last term it is very clear that BC is common. So let me take BC outside, and I am going to take which is not common. One is A bar, on the other term it is A plus, and similarly let me check that which terms are common again. Okay, so if I see that this 2 term is common, that is your B bar C bar is common. So what is there in your bracket? A plus A bar. Okay, so last term there is no solution for it. Let me have the same thing. So we know that from the law we are very clear that A plus A bar is equal to 1. Okay, so this will be equal to 1. Obviously this will be equal to 1. So this will be 1, 1. So you will be getting the equation as BC plus B bar C bar plus A B bar C. Further this, you can't simplify this equation. okay, because there is no common terms here. So if there is no common terms, we can't simplify this. So let us check the given equation with the RHS. While I'm going to compare the equation with the RHS, the first term is right because it is BC here, and what we got is BC, and second term is B bar C bar. So what we got is B bar C bar, and last term is A bar B bar, but we got A B bar C. So very clear that choice A is wrong. Let us go with the second choice. So what is the second choice? AB plus A bar C plus BC is equal to AB plus A bar C. So we can see whether RHS is equal to LHS. So before solving this, we have to understand one theorem which is called consensus theorem. What is consensus theorem in the sense? Consensus theorem. Consensus theorem. What is consensus theorem is? First rule is it should have 3 terms. Okay, first rule is it should have 3 terms. This is your first rule. Second rule is, what is the second rule is? The first variable in the first term and the first variable in the second term should be its complement. Okay, so the first variable in the first term and first variable in the second term should be the complement of the first variable in the first term. This is your rule number 2. Third rule is, so along with this variable, you can have any variable here for a choice. Let me take B as my variable. Along with the second term, let me take a choice C as my variable. Okay, while I'm going to take this, what is my third term will be? The product of the second variable of the first term and the second variable of the second term, that is BC. So it means B is the second variable in the first term and C is the second variable in the second term, and its product will be the third term. So this term will be called as redundant. Okay, this term will be called as redundant. So what will be the final answer for this is, as it is redundant, the whole equation will be equal to AB plus A dash C. So using this principle, we are going to check whether B and C choice is right or wrong. Let me apply the consensus theorem here. AB plus A dash C plus BC. So as per the rule, first variable in the first term is right, first variable in the second term is its complement, and the second variable in the first term and the second variable in the second term is the product in the third term. So this can be equal to AB plus A dash B. So this option is right. So B is right. Let us go with the third option. So third option, first we have to expand this A plus C into A dash plus B. So let me expand this equation. A dot A dash plus AB plus A dash C plus BC. So we know from the law A dot A dash is equal to 0. So let me make this as 0. And what is the remaining term? AB plus A dash A bar dash dot C plus BC. Okay, so let me check this with the consensus theorem. Already I told what is the consensus theorem. So first term should be a variable and the same variable should be the complement in the second term, and the second variable in the first term and second variable in the second term should be the product of the third term. If it is so, this term is redundant and this final answer can be AB plus A dash C. Let us take the answer with the given choice. Yes, obviously after solving this, we are getting the final answer as AB plus A dash C. So this choice is right, this choice is right, and we found that this choice is wrong. Let us go with the last option. Let me expand this by the De Morgan's theorem. So already we know what is De Morgan's theorem. A dot B dot C dot D, the whole bar will be equal to A bar plus B bar plus C bar plus D bar. Okay, using this I am going to expand this equation. So let me expand A plus B dash plus D bar the whole bar, because I told that A dot B dot C dot D whole bar is equal to A bar plus B bar plus C bar plus D bar. This is your A term, this is your B term, this is your C term, and this is your D term. Plus, let me take the second term, C plus D the whole bar, plus third term is A bar plus C plus D the whole bar, plus the last term is A plus B plus D bar the whole bar. Okay, again I can apply the De Morgan's theorem. We know the De Morgan's theorem, A plus B plus C the whole bar is equal to A bar dot B bar plus dot C bar. Using that we can expand this equation. So A bar as per the equation double bar dot B bar the whole bar. Okay. Okay, let us take the third last choice, which is the D choice. So we know that De Morgan's law. By De Morgan's law, A dot B dot C dot D the whole bar is equal to A bar plus B bar plus C bar plus D bar. By using that, we are going to expand this equation. A plus B bar plus D bar the whole bar plus C plus D the whole bar plus A bar plus C plus D the whole bar plus A plus B plus D the whole bar. Again, I can apply the De Morgan's theorem. We know that A plus B plus C the whole bar is equal to A bar dot B bar plus C bar. Using that, I am going to express this term A bar dot, already we have bar in this, so it is double bar dot D double bar plus, let me simplify this, A bar dot D bar plus, let me apply the theorem, A double bar dot C dot D plus, let me apply the theorem, A bar B bar dot D double bar. From this, let me check. We know that anything of double bar means the same term. So A bar dot B dot D plus C bar dot D bar plus A C D plus A bar B bar D. Now we can check which terms are equal. So let me see which terms are equal from the first. Okay. So I have missed C bar, D bar here. So C bar, D bar. So let us check, see which is common here. So from this I am very clear that from this two terms C bar, D bar is common. So remaining term will be 1 plus A. And similarly from the first term and the last term, A bar D is common. So let me take A bar D as common. So what is inside? B plus B bar. Again, let me apply the laws. While you are going to apply the law, it is very clear that B plus B bar or A plus A bar is equal to 1. And similarly, we know that 1 plus A is equal to A. So finally, so I told this is 1, I told this is 1. So finally, you will be getting A bar D plus C bar D bar. Let us check with our RHS. So what is RHS given here? A bar D plus C bar D bar. So it is very clear that option D is right, option C is right, option B is right. So which is wrong means option A is wrong. Already I told you that for all the questions, for some questions, you can't expect that there will be only one choice as the answer. There might be 2 or 3 choices. Okay. Thank you. We'll meet you in next session.